When most people think about fire, they think danger. But in reality, the removal of fire can also be very problematic. Here in central Arkansas, across our prairie and grassland habitats, we have had fire exclusion and suppression for well over 100 years. And that has led to a lot of shifts in our plant and animal diversity. Woody species are encroaching into our prairies and grasslands, resulting in a loss of biodiversity. To try to correct this issue, land managers use prescribed fire or man-made controlled burns to try to help reverse this issue and mimic historic disturbance regimes. My research aims at looking at how one of these species, sweetgum trees, responds to prescribed fire. So sweetgum is a resprouting woody species that is native to Arkansas and is taking over grassland and prairies. And so I'm interested in how land managers can best utilize prescribed fire to try to knock back sweetgum and help mitigate the woody encroachment. Sweetgum is a resprouting tree, which means that after it's been damaged from the ground up, it has the ability to regrow that mass. And so the question becomes, how can we best utilize prescribed fire to help knock back sweetgum? Well, one of the ways that we can control fire is through the season of when we burn. So we have 2 sites on Camp Robinson Special Use Area, one of which was burned in August of 2021, and the other site was burned in March of 2022 to replicate a summer burn when trees are very active and photosynthetically productive, and one when they are dormant and not as active in the environment. We followed these trees until December of 2022 to try to see and monitor how they responded for resprout growth, water resources, their carbon reserves and storage capacity. And ultimately what we ended up finding was that within that first growing year, there was no difference. Season of fire didn't seem to impact resprout growth. By December, both sites had the same height and mass of resprouts, which was a little disheartening until we dug deeper. We looked more into the root reserves, or the amount of reserves and carbon that those trees had stored to be able to grow and fight disturbance in the future. Ultimately, what we found was the trees that had been burned in the summer had significantly less root reserves. They had half as much starch as the trees that were burned in the winter. They were also much more water stressed in summer. What that tells us is that while we might not see results in that first year, summer burned trees for sweetgum here in Arkansas did a lot worse. And that information can hopefully help inform land managers on how to manage our lands.